Earth teeters on the edge of a food crisis as populations soar and resources dwindle. Traditional farming battles deforestation, water shortages and climate change, struggling to feed billions sustainably. Enter the Food Replicator, a visionary device born from Joshua Friend's research in 2025. This innovation synthesizes food from basic bioelements, carbon, hydrogen, oxygen and nitrogen, offering a lifeline to a hungry world. Imagine a machine that crafts meals molecule by molecule, bypassing fields and factories. In labs, scientists load cartridges with raw materials, aiming to revolutionize nutrition. As crops fail and cities swell, this technology promises abundance without ecological cost. Picture a family enjoying a replicated dinner tailored to their needs, or a child spared from hunger. The Replicator isn't just a tool, it's a new frontier, tackling food security head-on. With sustainability at its core, it redefines how we nourish humanity, blending science with hope for a thriving future. In a cutting-edge lab, the Food Replicator's heart beats with precision, chirality or molecular handedness. Life depends on it. L-amino acids build our proteins, D-sugars fuel our cells. Get it wrong, like using D-amino acids, and food turns useless or toxic, disrupting metabolism. Joshua Friend's research demands chiral fidelity, ensuring every molecule matches human biology. Picture a replicator assembling amino acids with enzyme-like catalysts, mimicking nature's finesse. Scientists peer through microscopes, guiding nanotechnology to sort left from right. Sensors hum, scanning each bond for accuracy. L here, D there. A single misstep could spell disaster, but success crafts safe, nourishing food. Visualize a steak forming, its molecules perfectly aligned, tested and approved. This isn't just chemistry, it's survival. The Replicator's promise hinges on this dance of handedness, turning raw elements into sustenance. Precision isn't optional. It's the key to feeding the future with science we can trust. In a bustling workshop, engineers craft the Food Replicator, a marvel of modern tech. It starts with the feedstock unit, storing bioelements like carbon and nitrogen in recyclable cartridges. The molecular assembly unit takes over, using nanotechnology and biomimetic catalysts to build precise molecules. Next, the food formation unit bioprints these into textures, think bread or steak, adjusting heat and feel. Powering it all is an energy system with graphene supercapacitors and solar-fed batteries, efficient and green. Quality assurance kicks in with spectroscopic sensors and AI ensuring every bite is safe and right. Titanium alloy and borosilicate glass form its sturdy shell, designed for durability. Modular parts snap together, making it scalable. Watch it hum to life, churning out a warm loaf from raw atoms. This isn't sci-fi, it's Joshua Friend's blueprint brought to reality. Each component syncs in harmony, turning elements into meals, proving technology can solve hunger with ingenuity and care. In a testing lab, the Food Replicator faces hurdles Joshua Friend foresaw. Chirality trips it up, diamino acids sneak in, threatening safety, engineers deploy biomimetic catalysts and chiral filters, nailing L-amino acids and D-sugars with precision. A green light confirms victory. Energy demands soar next, draining power fast. Gallium nitride diodes and waste heat recovery/consumption, keeping it green and efficient. Scalability looms large. Complexity could spike costs. A modular design simplifies it, dropping consumer units from $20,000 prototypes to $3,000 in mass production. Watch the Replicator churn out meals, each test refining the process. Screens flash success. Chirality fixed, energy optimized, scale achieved. This isn't easy. Every tweak solves a puzzle, from molecular mix-ups to budget barriers. Yet, with grit and tech, the team turns challenges into triumphs. The Replicator's future hinges on these fixes, proving innovation can feed the world affordably and sustainably. In a high-tech haven, the Food Replicator's magic unfolds through advanced tools. Nanotechnology leads to scanning, tunneling and atomic force microscopes move atoms with pinpoint accuracy, crafting molecules from scratch. Biomimetic catalysts inspired by nature's enzymes ensure L-amino acids and D-sugars form flawlessly, mimicking life's own builders. AI takes the helm, its algorithms spotting errors in real time, learning and perfecting each run for efficiency. Materials elevate it all. Graphene boosts conductivity and strength. Borosilicate glass resists heat, and titanium alloys anchor the frame. Watch them sink. A microscope positions carbon, catalysts shape proteins. AI greenlights the process. An apple emerges pristine and edible, born of this tech symphony. Joshua Friend's vision thrives here, where every tool pushes boundaries. These aren't just gadgets, they're the backbone of a revolution, blending precision and power to turn bioelements into sustenance, paving the way for a nourished world. The Food Replicator steps off the lab bench into lives worldwide. In a suburban kitchen, a family crafts gluten-free pasta, tailored to their needs, convenience without waste. Aboard a spaceship, astronauts print nutrient bars, self-sustaining for Mars missions. In a disaster zone, aid workers deploy units, serving hot soup to survivors within hours. In a rural village, a community replicator churns out fruit, banishing hunger from kids' faces. Joshua Friend's brainchild tackles food security head-on, offering personalized nutrition at home, resilience in crises, and hope in underserved regions. Imagine astronauts free from supply chains, or relief arriving not in trucks but in molecules. Stats flash, billions fed, waste slashed, sustainability soared. From households to orbit, this tech adapts, delivering what's needed where it's needed. It's more than a machine, it's a lifeline, weaving equity and innovation into every bite, ensuring no corner of Earth or beyond goes hungry again.